Good morning, children. Good afternoon. Good evening. These kind of questions, if you read the questions, you will understand, is based on the molecular orbital theory, right? So these will be appeared or will keep on asked in JEE, NEET, okay, different kinds. The species like O2, O2 minus, O2 plus, O2 2 minus. One more you can join is O2 2 plus. The questions will be different. Okay, so it may be asked in JEE, NEET, or CET, or even for teaching exams where you're writing chemistry test. Okay, so how to do it within 10 seconds? Okay, only one trick I will tell you. If you remember that any kind of question they ask in out of these three, or even one more question, it can increase in the bond length, increasing or decreasing order, you can do it very well within 10 seconds. The trick here is, first you write the all 5 species O2 2 minus, like increasing their charge. Okay, so minus 2, increase 1, minus 1, increase 1 0, increase 1 more, plus 1, increase 1 more, plus 2, right? This is the increasing order, minus to plus. In that way I am telling you. So then the last one will have the highest bond order, so you will write like this: increasing bond order. So this is bond order increases across this. You just write this one point and all other questions you can answer based on this. So first question, if they ask you arrange them in increasing or decreasing bond order, you will directly write like this: negative charge to the positive charge, increasing the charge. Okay, one more thing, you can also know what is the bond order for each of these species. How? Oxygen, you know that by now we know oxygen has a double bond, so it will be 2. So as the number goes negative, it decreases, it becomes 0.5 less, then it becomes 1 more, 0.5 means 1. As you go to the positive, the 0.5 increase will be there, so it will be 2.5, and this will be 3 for O2 2 plus. Therefore you can see the bond order is increasing. And some more points, you can, what you already know, that bond order increases means what happens to bond length? Bond length decreases. Bond length decreases because the atoms will come closer and closer together when the bond order increases. Means bond length decreases. What happens to the bond dissociation energy? Right, what happens to the bond dissociation energy? It will be directly proportional to the bond order. Directly, if the bond order increases, bond dissociation energy also increases. It means you need less energy to break single bond, more energy to break double bond, even more energy to break triple bond, right? So therefore bond order increases, bond dissociation energy also increases. Then one more question will be asked: what about the stability? Stability also depends upon the bond order directly. Means more the bond order, more the number of bonds between the two atoms, more stable is the molecule. Okay, only one inversely proportional is bond length. As bond order increases, bond length decreases, and all both bond dissociation energy, bond, and also the stability are directly proportional to the bond order. Now easily you can solve these all questions on your own. Okay, let's see. Increasing order of the bond order of this, we have already written that in the previous slide. Next one, decreasing order of stability. So first what you will do, O2 2 minus, you will write in the order, then O2 minus, then O2, then O2 plus. So as you go from left to right, bond order increases, means stability also increases, but they have asked to decreasing order, means you have to come back. All right, O2 plus, you will write first, then O2, then O2 2 minus, O2 minus, then O2 2 minus. So you again, you should be careful whether they are asking increasing or decreasing. This is decreasing stability. This will be, if I write like this will be increasing stability, this will be decreasing stability. which of the following orders is correct for the bond dissociation energy? Okay, no need to see the options as well. You already know bond dissociation energy increases with bond order. So again you will write what are species given: O2 2 minus, O2 minus, O2, then O2 plus. Again O2 2 plus also you can include here. So just write increasing. Okay, you have to see there in the option. So this will be either in increasing. So bond dissociation energy should be in the increasing order. So this will be the correct option. Bond length, what will happen if you take? Bond length will decrease. So then O2 plus will be having the smaller bond length than O2, then O2 minus, then O2 2 minus. It means here one more O2 2 plus also you can include. Okay, this is increasing bond length. Increasing bond length. Decreasing means you will write in the reverse order. Okay, so apart from this there will be one more type of question here. Which of the following species are diamagnetic? So there are two concepts called paramagnetic and diamagnetic. Again, what is the trick here? Diamagnetic. I am telling this trick only for these species. Remember, O2 is paramagnetic. If you know in the second period elements, all elements, okay, only two are paramagnetic: boron and oxygen. These two are only paramagnetic. There are some molecules which do not exist, like He2 and beryllium 2. Also, noble gases, they do not form molecules. So these do not exist. Apart from these, whatever are there, okay, H2, Li2, H2 is first series anyway, no problem. Li2, okay, C2, then O2 is already there, N2, F2, these all will be diamagnetic. Okay, so but he has asked in the given options O2 plus, okay, O2, O2 minus, O2 minus 2. Remember, for oxygen we have two unpaired electrons. Two unpaired electrons. Paramagnetic behavior is due to unpaired electrons. If there are no unpaired, then they are called diamagnetic. So then oxygen has two unpaired. You write it separately because they are in pi. Okay, so you will write like this. They are always, they will be filled half. Okay, now if you remove one electron, there is still one more, right? Already you know O2 is paramagnetic, so this option is wrong. We have to see other options as well. One electron, if you remove, what happens? O2 plus will be there, but still there is one unpaired electron. So this is also paramagnetic. This is also paramagnetic. O2 minus, if you come, you are adding one electron, then one more electron you added, still there is one more unpaired electron. This is also paramagnetic. O2 2 minus, if you take, there will be paired. All of them will be paired because to oxygen you are adding two more electrons, right? It will become 4 electrons, all of them paired. So this will be diamagnetic. Okay, if you think O2 2 plus, what you can check, what you can say, you have removed this electron also, then there is no unpaired electron. You can say O2 2 plus is also diamagnetic. O2 2 plus and O2 2 minus, both, whether you add two electrons or remove two electrons, then both of them will become paramagnetic. Okay, so the option is O2 2 minus is the diamagnetic out of these two. Okay, so I hope you like this video. We'll make more videos like this. Take care. Bye bye.